Hey, what's going on, guys? This is Dave from DR Refugees. Today I just wanted to make this video to sort of demystify the project and to make the project more accessible to people who want to contribute or who want to understand what the reverse engineering process is like for the game. So today we're just going to briefly touch on how the game works, a little bit of an intro to reverse engineering, and talk about some tools that I use in the day-to-day process. So to fully understand what's going on, I recommend having a basic computer science knowledge or understanding. Some of the topics that we're going to be talking on are a little complex in terms of like hex numbers and binary and whatnot, and it helps to have some basic like programming knowledge or past experience in computer science to sort of understand those kind of topics. So I'm going to go over like a very broad overview on some of these. So some of these topics, like assembly language, for example, we're just going to barely scratch the surface, where you can dig like tens or hundreds of feet deep. So with that being said, like a lot of this can get kind of confusing, and reverse engineering itself is pretty complicated. So in order to understand what's going on, I do recommend doing some outside reading or video watching or whatnot on some of these topics, like assembly language, just in order to get a full understanding of what's actually happening. And feel free to ask any questions too if anything is unclear, so I can always make another video in the future, touch up on any of this stuff that might not be very clear. So with that being said, let's dive right in. So first off, I just wanted to touch on the VMs that I use for development and for running the game and the server. So first off, I have a Windows 7 client VM, which basically just runs the game client and a few reverse engineering tools. And then I have a Ubuntu VM, which runs the Python server from GitHub. And the two of these are on isolated networks that can only talk to each other. So it kind of makes it easier during the debugging process if I have to look at like a Wireshark capture or something of the network. So the VMs definitely aren't like a requirement. It's going to be a hassle to set up like a Windows VM, for example. You can just run everything on your local machine if you run Windows. So both the client and the server will run there. So don't stress over the VMs if that's going to be an issue, but it just makes it a little bit easier for me. So next I just wanted to talk about a few tools that I use on the day-to-day. Up first we got the hex editor. This is HXD, but you can really use whatever works for you. There's a bunch of different programs out there, but they all basically do the same thing. So your hex editor basically allows you to manipulate data in hexadecimal format. And the value of that is if you have some network traffic, like coming from the client to the server, for example, you can basically copy that in here and can look at each individual byte, and you can manipulate them and change stuff around. So if you were to copy that into like your regular text editor, like Notepad++ or whatever, it usually doesn't have an option to view it in hexadecimal format, which are these numbers over here. So the 68, 65, like these are all hex numbers. So I typed hello over here. This is the ASCII representation, and the hex editor basically just shows the hex version of that. So these hexadecimal numbers, each of these is a character in the message. So this is H, this is E, and so on and so forth. So the value of this is you can manipulate binary data a lot more easier in its hex form. So again, like data coming back and forth between the client and the server. Really easy to manipulate that and play around with it in the hex editor. So up next we have our disassembler. I'm using IDA. There's a few other options you can use, but IDA is generally the gold standard when it comes to disassemblers, and also for debuggers, which we'll be talking about in a few minutes. But in order to understand the value of the disassembler and the debugger as well, we kind of have to think back to the process of compiling code and how the code sort of goes from the high-level C++ code down to assembly language, which is what we're looking at. So the developers for the game wrote the game code in C++, and when that code is compiled, it's turned into what's known as machine language, which is basically what the computer can understand. And the disassembler comes in to basically take that machine language and bring it up to a somewhat human-readable form known as assembly language, which is what we're looking at right now. So the real value of this tool is that we can use this assembly language here to basically infer what the original high-level C++ code looked like. So we don't get an actual accurate representation of the C++ code in the assembly language, but we can basically step through each of these assembly instructions and infer what the original code looked like based on what the assembly output is. So we're basically just trying to backtrack that compiling process and trying to get back to the original C++ code by looking at the assembly language. So the power of IDA is it makes it really easy to visualize what's going on in the client program, and we can actually switch into what's known as graph view here, and we can basically look at this huge function in terms of the blocks of assembly code here. And this is a really huge function, so there's really a lot going on here. You can see this huge graph over here of all this different code over here in the client, but basically the takeaway point is that we can use this tool to look at the client's code and to see what it's doing from a visual perspective. So on the flip side of this, we have the debugger. And the debugger is basically used to analyze the game as it's running. So we can see the internal state of the program as it's being executed. So in terms of like our CPU registers, the call stack, memory, and all that good stuff. And you can see each line of this assembly code being executed and see how it changes that internal state of the program. So as an example here, we've got our player read object function. This is basically called every time the server sends a player to the client, sends a character. And if we were to set what's known as a breakpoint here, go up here and click add breakpoint. So this will basically tell the debugger that every time this function is reached, every time this line of code is about to be executed, we're going to stop executing the program, so stop the game client, and we're going to pause the program so that we can basically step through each line of this assembly code and see how it changes that internal state of the game. So if we go up here and start our game client, you're going to see it pop up right over here in the corner. So the game client right now is being debugged by IDA, so the debugger is actually attached to this running process. And we're going to log in, and hopefully this will work the first time. Sweet. So we got our characters sent from the server to the client, and the debugger saw that we were entering this player read object function, and it stopped executing the code. So you can see here the game client is pretty much frozen because the debugger stopped it from executing. And we can see our registers over here, we can see the stack, and we can basically step through each of these lines of assembly code to see how this internal state changes. So for example, like if we were to click over here, this basically steps through each line of assembly code. We can see some stuff changing around. Again, we see some registers being changed, and we can like push some stuff onto the stack down here. And the use of this is basically when we're trying to debug what's actually happening in the client code. It's a lot easier to step through it in a debugger rather than just trying to look at everything in your disassembler and to see, trying to imagine what might be happening on the internal state of the program when you can just actually execute it and see for yourself. So this is basically where the debugger comes in. If there's like a certain function that we want to analyze, then we'll do what we just did, like we set a breakpoint on it and sort of look around. So we went over some tools. Now I just want to go over basically an overview of the game files themselves and talk about what each file contains and its purpose. So up first we have the main executable, the actual Dungeon Runners client. This is the version 666 client, so this is basically the last release before the game went down. Other versions have different versions of the game protocol, and those basically behave differently than the version that we've been targeting with all this reverse engineering effort. So right now the only version of the game client that's actually supported by the server is the version 666 client. So the version, I think it's 118, that was included on the CD isn't officially supported. It might be at a later time, but right now, just due to the protocol differences, we're just targeting this version 666 version of the Dungeon Runners client. So up next we have our config folder. So if we go in here, we see a bunch of different files. Basically right now the main file of note is this dungeonrunners.cfg. So if we open this up, I've already got it open in Notepad++ here, but this basically contains these auth server and resource manager directives. The one of note is the auth server. So this is basically where we specify what our client should be trying to connect to when it goes to authenticate to the game. So before this was, I believe, auth.dungeonrunners.com, and we just changed this to a local IP. So I actually changed this to the IP address of the virtual machine that's running the Dungeon Runners server right now. So we just basically point this at our internal server so that it tries to connect to us instead of trying to connect to the actual Dungeon Runners authentication server, which currently doesn't resolve anything, so it just wouldn't do anything otherwise. Next we have our logs folder. So this is basically where the game logs a lot of stuff about what's actually happening as the game is executing. So we have this file open here. We can just take a look through and we can see a whole lot of different information on here. A lot of this is like, this is graphics related down here. Some of this is like authentication. So there's a whole bunch of stuff that gets logged here. The main value of this is we can see first off, like which functions are actually logging this log message when the game is executing. So if we wanted to trace back to see what the game is trying to do as it's creating these log messages, or like if there's an error, like where's the error occurring, then we can actually look at like the function that this log message is occurring from, and we can see like, oh, world attach object, this is doing this stuff with the world, and that's where we can sort of trace back and see what's going on within the game binary. So this is very valuable when the game actually does log this information. Not everything is logged in the game, so sometimes the game just won't be helpful and it'll just sit there and not do anything when we're trying to figure out what's going wrong. So that's when we dive in with the debugger and the disassembler, which we just talked about, to try and figure out what's going on. But sometimes the game actually does log some pretty helpful information. So like, we can see the connection to game server authorized, and client now connected, and stuff like that. Stuff that has to do with the protocol generally is usually really helpful when you see it being logged in here. So finally, we've got our game assets. The two files we're going to be looking at here are the game.pkg file and the game.pki file. So you can ignore all these Dungeon Runners whatever files up here. These are all created by IDA, and the two we're going to be looking at are the pkg and the pki files for the game assets. So we can immediately notice that the bigger of these two files is the game.pkg file. So this one is 622 megabytes. So this is basically where all of the files that make up the game are stored. So like the models and the sounds and the textures or everything, these are basically all within this one big PKG file. So basically each of these individual game assets are compressed and then basically all balled up into this big PKG file over here. And in order to extract these, I used a program called OffZip, which I can link in the video description. But basically, what the program does is it takes this huge PKG file and looks for each individual compressed game asset inside, and will decompress the game asset and store it in a different folder. And it'll just keep going through and basically extract all of the game assets that are stored within this big file. So for convenience, I already have all these files extracted and opened up over here. And we can see there's just a whole lot of stuff in here. So there's many different game assets. You can basically ignore the file extensions over here and the file types, because these are basically just what the tool does is it takes the first three characters of the file and makes that the extension. So don't actually try and Google what each of these file extensions mean, because they're mostly useless. But so I opened up one of these files over here in our hex editor, so you can sort of see the value of where this comes in. So for example, on this one asset, we can see that there's actual ASCII text that shows up in here. So this is actually readable words and letters and stuff. Whereas some of them, for example, this is just a whole bunch of binary data. So this is where the hex editor comes in. So we can actually manipulate this using these hex numbers over here. Whereas in ASCII, you really can't see what each of this, what this data is, but in hex you can sort of, you can see what the binary data actually is for each of these files. So one of the other cool things about the game assets is if we go back to this file over here that actually has the readable characters and words over here. If if we were to open this in Notepad++, we can see that there's sort of like a script-like format to this file over here. And some of the game assets basically use this format in order to define data. So like, for example, we can see there's this unique ranger body IG. And within there, it extends like a few different classes. And there's a few like variables being set. So like we can see chances being set to 1, and like there's some other information is being defined here. And this is basically how the game is able to pull that data and to store it locally on the client side. So basically, instead of sending all this from the server every time, this is all just stored locally in the game assets. So one of the issues with the package file is, since there's so many different game assets inside and there's so much data, it's kind of hard to find what you're looking for when you're looking for a specific thing, or you want to do a search, for example. You really can't like open up each individual file and look through it to see if it has what you're looking for, just because there's so much information there. So one of the tools that I use to sort of work with that is within this Linux shell that I have here. So there's basically a Windows equivalent to doing this. I'm using the Bash for Windows thing on Windows 10. But there's all sorts of different. You can use like Windows equivalents of these commands either. So basically, I'm just going to change directory into the output folder of the offset tool. So basically, if we were to look at this folder, this basically has all of our game assets there. So what we're going to do is use grep, which is a command line tool, recursively, which is going to look through all of these files, basically one after the other. Just going to do a search on everything in this folder, and we're just going to look for something really basic, like our avatar, for example. So we're just going to let this run. It's going to sift through basically all of these game assets, and it's going to bring up any files that have the name avatar within them. And from there, we can sort of look at when the results come up, we can look at the file that actually contains the definition for the avatar game asset, and we can sort of see what's defined in there. So after letting this run for a few minutes, we can see it found a lot of stuff. I'm basically just going to cut this off because we already found what we needed. But if we go way up here, you can see that there's a lot of different files in here that contain the string avatar. But if we just go way up, back up here a little bit further, there we go. So we can see up here that the very first file that came out of here is it says avatar extends avatar, and this generally, when you see that type of like wording over here, something extends something else, that's basically the definition file for this avatar object. So we're going to find this. I'm going to take this file name over here, and we're just going to open this up in Vim, which is another text editor, but it's basically going to show us the contents of this file. So we can basically look through what is actually defined in the avatar game asset. So we can see over here it has hit points, it has mana points, it has what's this node over here, description, which I'm going to talk about what nodes actually are later on in the video. But it has the description, it has a PvE start sector, it has default skills object, default bank object, and all this stuff is within the avatar file. So you can pretty much do the same thing for pretty much any game asset. You can sort of grep for the definition file, and then find the definition file and just look at what's actually defined inside. And that's a really common technique that I used for a lot of the project up to this point. So finally, we have our game.pki file. The PKI is basically the index into the PKG, so it basically says what files are located where. And if we open this up in our hex editor, we can basically see it's the same, just lots of binary data. So we actually haven't been able to fully reverse engineer this file yet and understand the contents fully, but we haven't really needed to. On the other hand, just because of that grep technique that I just showed you, is what I've been doing for pretty much all of the game assets up to this point. So this file is basically just the index into this huge PKG file, which again is just compressed data, but we haven't really needed to use the contents of this file yet. But just so you know what it does, it's basically the index file into the PKG. So shifting gears a little bit, I'm going to talk about the game internals and the little quirks that make up the game. The disclaimer for this section is that the internals are still being actively reverse engineered, so Some of the stuff I'm going to talk about is subject to change, so it might totally be different like a year down the road if I find out more information about some of the game internals. But most of the stuff I'm going to be talking about I'm pretty certain is accurate, so just take it with a grain of salt and keep that in mind that this might not stay, this might not be current a year in the future. So first up is the servers within the game. So there's basically two sides of this. There's the login server and then the actual game server. So the login server is basically just for authentication stuff. So basically just logging in with the username and password, and then you choose a world and you are connected to a game server. So if we were to open our DR client here, and it's super tiny so that it doesn't show up like right in the middle of the disassembler when I'm trying to work on the file in IDA. But if we were to just log in here, actually I can just blow this up. So we can see we can choose a world to actually play the game on. This is all the auth server stuff, and then as soon as I hit OK, it's basically going to shift gears and disconnect from the login server and then connect to the game server. So right now it's actually connected to the game server and totally broke off from the auth server. Basically anything up to this point is the actual login server or the authentication server. The good news is that the login server for the game uses the Lineage 2 protocol revision 785A, which is an older version of Lineage. I forget the actual release name or anything like that, but this protocol is publicly documented and has been reverse engineered by other folks almost 10 years in the past. So we're basically able to take this Lineage 2 protocol and just implement that for the Dungeon Runners server. And that basically means the login server is pretty much a solved problem at this point, which is good. Basically the login server's main goal is just to authenticate the user connecting to it, and then to give them a list of game servers to connect to. And then when they pick one, they disconnect from the login server and then connect to the game server. So on the other hand of that, the game server has been pretty much the main focus of the project. So the game server is what actually does everything else in the game. And from what I can tell, the game server is broken up into a bunch of different smaller components, which I'll be talking about in a few minutes. But basically, you can think of the game server as just one big entity that just does the actual gameplay. So the game server actually uses its own custom protocol, and that's basically what we've been trying to reverse this entire time, is this game server and its custom protocol that the DR devs made way back in the day. So next I wanted to talk about some of the important prefixes that we're going to see throughout the game client. The first of which being GC. So we see over here I have a bunch of functions for the GC object. So we can see that there's all sorts of stuff like copy property values and read and write object and stuff like that. So GC is basically anything having to do with static game assets. So basically the things that are found within our package file. So over here I have our GC object, read object function, and we can see here if we go to the cross references of this function, so we can basically see where this function is being called throughout the game client. So we're just going to click on the mangled name over here, the symbol name, and hit X to look at the cross references. And we can see pretty much everywhere where this function is going to be called throughout the game client. And you can see it's called pretty much all over the place. There's lots and lots of references. So over 300 times, over 300 different locations throughout the game binary this is actually called. And a lot of these are for these read object calls over here. So basically when objects are being read from the server to the client, so objects are being serialized, this GC object is used to actually fetch objects from the game assets. So our other important prefix is DFC. So if we go over here to the functions and type in DFC, and just to take a look at everything, every function in the game that has DFC in it. We're just going to start looking through. We see all sorts of stuff here. So this takes a DFC event light. Let's see what else. DFC control, DFC node, DFC matrix, DFC event, DFC control. If you go a little bit farther down, DFC message, DFC event. There's all sorts of DFC stuff throughout the game binary. And the reason for that is basically because DFC is the prefix for pretty much just how things are done in the game, or how things are represented. So pretty much any dynamic or changing object is going to have some sort of DFC class associated with it. So there's things like DFC objects, DFC classes, DFC messages. That's just how things are represented internally in the game. So like if we open our game binary, for example, like a UI buttons, those are going to be DFC objects. Like the actual player character itself is going to be a DFC object. So DFC objects are like serialized and sent over the wire in order to transport data and things like characters and whatnot. So basically, like, DFC objects are just how stuff works in the game, and they're pretty much all over the place because that's pretty much what the game is constructed around, is these DFC classes and objects. So there's pretty much a DFC object for almost anything in the game. So over here I just have a little Python representation of a DFC object that I created a few weeks ago. This little Python script basically just makes it easier to create DFC objects and sort of breaks down what they're composed of. So we can see over here in the init method over here that in order to make a DFC object, you need a native class, a node ID, a node name, and a GC class. So I'm just going to sort of step through each of these and talk about what they are. So first off, the native class is the DFC class that the DFC object will be an instance of. So again, kind of going back to object-oriented programming, you have classes and objects. So the object is basically an instance of a class. So your native class is basically just things that are found in the actual function list of the game. So like, for example, if I was making a player, then my native class would just be player. The node ID and the node name are actually something that's kind of uncertain. I'm not really sure what those fields are for, but one is basically a numeric 4-byte like integer that's used to, I think, just identify what the DFC object is, so that it can be accessed later on. And then the node name is basically just a string that's associated with the object as well. Not really sure what those are used for at this point, but again, that's one of those things that's subject to change in the future. So next, the nodes are basically just like nested children of this DFC object. So you can actually have a DFC object that is a node of another DFC object, and they can basically, you can set up the hierarchy like that. So again, just think like a parent-child relationship for these. And then the GC class is basically your game code, your game asset that the DFC class is going to be based around. So some objects actually are based solely on like static game assets, so you're pretty much required to supply a GC class sometimes, but other times there's just no game code object that's associated with an object, so you can pretty much just specify the same thing as the native class. It really depends on whether it's actually trying to pull information from the game assets or not. And then the properties down here are basically like key value pairs to add additional data to your object. So like, for example, when we're creating the player characters, in order to name the character, I needed to specify a property with a key of name and the value of the character name. So like the please work name that I've been using throughout pretty much the whole project. So the properties are basically just those key value pairs to supply extra information for the object. And then this extra data field is just any extra information that should be included with the object when it's serialized over the wire. So lastly, I just wanted to talk about some of the internal systems in the game, which are basically like a bunch of separate components within the game that each perform an individual function that basically all culminate to support the functionality that's within the game. So, for example, that might sound kind of convoluted, but hopefully it will make sense in a few minutes. So if we look at our user manager client, which is the first of these little components, if we look at all the user manager client functions, let's go down here. So there's basically a whole bunch of functions over here that are associated with our user manager client. So we see things like request rosters, is contact, is ignore, set busy, request user list, set friends, publicity. So our user manager client is basically stuff that has to do with our friends list in game. So if we look at each of these little clients has a process message function here. So we can open this up and basically look at all the functionality that each of these can do when you send it the right packet over the network. So like there's all sorts of stuff like, add ignore message and remove ignore message, and so on and so forth, like just stuff that has to do with the friends list. So that's our user manager client. We also have the character manager client. So again, we're going to look at our process connected message. So character manager client is basically, as I bet you can imagine, just receiving, creating, deleting characters, just stuff to do with characters in the game. So we have methods over here like request characters, delete character, or create characters, delete characters, select character, just stuff that has to do with in-game characters. So again, if we look at our process message function, we can see that there's basically this whole chain of functions that can be called based on the input from the server. So all these functions that we looked at are basically all callable based on the network traffic that you send the game client. So our character manager client has to do with our characters. We also have the chat client. So as I bet you can imagine, for the chat client, it's basically, let's get the right set of functions there. Here we go. Just stuff that has to do with the in-game chat. So we have things like join channel, leave channel, send chat message. And again, all these are callable from our process message function, so I'm not going to show that again. But the chat client is basically just stuff to do with in-game chat. We also have our client entity manager, which is for creating and updating the game entities that the server sends to the client. So basically just used to sync our game client to what's happening in the rest of the world, basically. So if you look that up, way back at the top up here. So there's all this stuff like entity create, entity init, component create, component init. So that kind of goes back to the entity component model in game design. But there's basically all these functions for maintaining the entities within the game. So again, process message, pretty much. This is a really big function over here. So zoom out a little bit, but there's just all sorts of entity-related functions that can be callable based on network input. So if we look at some of these, it's basically component update, component init, just stuff that has to do with like game objects, and basically just syncing the client to stay current with what's happening on the server. So that's all within our client entity manager. We also have our group client for in-game groups. Here we go. So again, like lots of stuff that has to do with groups. So there's like dueling, setting our leader for the party, inviting users, declining invites, all that sorts of group stuff. Again, all this stuff's callable from our process message function. So group client is for in-game groups or parties. There's also the trade client for in-game trade. Where are we? Oh, just added. There we go. So the trade client is basically just stuff to do with in-game trade, so like accepting trade, requesting trade, lots of processing functions related to in-game trades. So again, process messages function basically handles all that. So trade client is for in-game trade. We have our zone client, which has proven to be very elusive over the years for me. So this is for changing and loading into game zones. So if we bring that up, there's stuff like transferring characters to respawn points, the progress for the actual zone load. So this is actually kind of shorter. So there's basically like a process connected where you basically specify the zone that you want to load into, ready, and then disconnected for when you're leaving that zone. So there's not as many functions here as other clients, but the zone client is basically for loading in and out of zones, and obviously this is still subject to change because we haven't actually loaded into a zone yet. But yeah, so your zone client is basically just for transferring your character back and forth between different zones in the game. So finally we have our posse client, which is basically handles all the stuff for posses in game, or the equivalent of guilds pretty much. So kind of similar to the group client, there's all sorts of stuff for like accepting invites, declining invites, joining posses, leaving posses, kicking members, all sorts of stuff. And all these functions again are called from the process message function. So these process message functions basically take a unique identifier to basically for the server to tell the client which function they want to execute. So like basically all these little blocks over here for calling each of these functions all trace back to one big little jump table over here, and basically these are executed based on a single byte up here that the jump table will jump to any one of these little switch statements down here based on that single byte within the packet that we send to our posse client. So when the game client is connecting to the game server, there's a special sequence for connecting with and communicating with each of these little systems that we just talked about, each of these clients. So I'm not actually going to go into details in the video here because a lot of the stuff, again, is subject to change and will probably be irrelevant in a few weeks or a few months or whatever when I uncover more information about the game. So instead I'm just going to write all that up on the wiki over the next few weeks, and hopefully just let that stay as the current updated source of information instead of trying to make new videos every time there's new information. But basically the takeaway point is each of these little clients that we just talked about, you have to talk to each one of them in a specific sequence, and you have to basically send the right information to some of those functions in order to make the game do stuff, like in order to receive characters and in order to load into the game and stuff like that. So the real challenge has been to figure out what that sequence is and what data you have to send each of these clients in order to get the game client as a whole to do what we want, which is basically to choose a character and load into the game at this point in time. So that pretty much covers everything I wanted to touch on in this video. I might do another one of these as I learn more about the game, just sort of as an update. For the finer details of some of the stuff I glossed over in the video, like the connection sequence or other like implementation details, check out the wiki. So I'm going to be updating that soon, and that will continue to be updated as I learn more about the game. So the video, again, I just kind of wanted to touch over like some very general patterns and stuff like that, stuff that really wasn't subject to change, and then a lot of the finer details I'm going to be putting up on the wiki, just because that stuff probably will be changing a lot. So let me know if you have any questions. I'd be glad to do another one of these videos to provide some more detail in an area that I might have skipped over, didn't cover very well. So let me know. I'll be happy to do another video, and thank you for watching.